Hello, Einstein. Ready to play some softball? On my softball team, 5 of the players' numbers are primes. If the sum of these different primes is odd, this sum could be... The answers given are 40, 39, 35, 27, and 25. This problem requires us to test the answers given. Hopefully, we'll be smart about it and we won't have to test all the answers given. Right away, applying a little reasoning, it can't be 40 because that's not odd. 40 is even. This problem requires you to know your primes. Let's start listing out our primes. If there are 5 primes, and the number in between this group is about 35, then we know we're looking for an average number that's about 35 divided by 5, which equals 7. So we're looking for primes in and about 7. We're not looking for 57 or 97 or some other crazy prime. It's going to be a bunch of primes in and around 7. The lowest prime starting from the first, which is not, by the way, 1. 1 is not a prime. The first prime and only even prime is 2. 3, 5, 7, 11, 13, 17, and that's probably sufficient number of primes in and around 7 to get us going for our answer. So why don't we start as a guess with the lowest primes, with 2, for example. And it looks like this might be a little low because 7 is the 4th prime. We only have 5 numbers. But we'll just start there to get going. 2, 3, 5, 7, and 11 are the first primes. So their sum is 2 plus 3 plus 5 plus 7 plus 11 equals 2 plus 3 is 5 plus 5 is 10 plus 7 is 17 plus 11 is 28. And as we suspected, that is a little lower than our average. And in fact, it is higher, though, than 2 of our answers. And this is the lowest possible sum of primes we could get. Note, since we included 2, and 2 is the only even prime, and the other primes are odd, and we have 4 of them, and we know an odd plus an odd makes an even, we know 4 odds must make an even, plus 2, which is an even, will have an even result, which is what we got with 28. And we know the answer, again, must be odd, so actually that cannot be correct. We must not have a 2 in our result. We can also draw another conclusion, is that the lowest sum of 28 is greater than 27 and 25, 2 answers provided. Therefore, we can eliminate those 2 answers. So what we're really looking for is 39 or 35, and we know we have to eliminate 2 in order to do that. So why don't we replace the 2 with the next higher prime, 13, instead, in which case our summation now becomes, instead of 2, it's 13, plus, again, 3 plus 5 plus 7 plus 11, and this in turn equals 13 plus 3 is 16, plus 5 is 21, plus 7 is 28, plus 11 is 39. And 39 is one of our 2 answer choices, so that must be the correct answer. That is the sum we can make with 5 unique prime numbers. With a little logic to aid our process of elimination, we didn't have to take too many steps to zero in on the correct answer. I hope this helps. Good luck.